Hello, I'm Terrence McNally. Welcome to Free Forum, a world that just might work. This episode was recorded as a live Talks LA event, May 5th, 2023, in Santa Monica. In it, I speak with theoretical physicist, futurist, and best-selling author MICHIO KAKU about his latest book, Quantum Supremacy: How the Quantum Computer Revolution Will Change Everything. You can learn more at mkaku.org. That's mkaku.org. On Free Forum, we explore the lives, the work, the ideas of individuals that I suspect have pieces of the puzzle of a world that just might work. We look at politics, economics, environment, science, health, culture, all based on the fact that I believe we can do better, and I want to find out how. The show streams weekly on the Progressive Voices Network on TuneIn.com, and podcasts are available anytime, anywhere on Apple Podcasts, Spotify, Google Podcasts, most major podcast sites, and at my site, terrencemcnally.net. TERRENCEMCNALLY.net. If you're like me, you've been hearing about quantum computing for years. And since you chose to come here tonight, I'm assuming many of you are more knowledgeable about it than I am. I confess I didn't really understand much about it until I started preparing for this interview. So here's our chance. We'll try to squeeze it all in to get a sense of what it is, how much it might change our lives, where we stand now, what the obstacles are, how we overcome them, the promise, and maybe the warnings, right? And let me put out there that tonight's guest believes it might eventually illuminate I'm quoting him, the deepest mysteries of science and solve some of humanity's biggest problems, including global warming, world hunger, and incurable disease. He says there's not a single problem humanity faces that couldn't be addressed by quantum computing. Michio Kaku is a highly accomplished and respected theoretical physicist and futurist, correspondent for CBS This Morning, host of 2 weekly science radio programs, the author of many best-selling novels, but the way you responded, you guys know that, including The Future of the Mind and The God Equation, The Quest for a Theory of Everything. Hi, Michio.
Hi.
I like folks to get a feel for the people, not just the books and the ideas that we might talk about. So share with us a little bit about your path, and feel free to go back to childhood experiences, turning points, mentors, that sort of thing.
Well, after such a great introduction, I can't wait to hear the speaker myself. Let me say, first of all, I'm a local boy. I was born in San Jose and grew up in Palo Alto. And as a child, I was fascinated by the things that make the universe move. And then when I was 8 years old, something happened which changed my life completely, set me off in a totally different direction. All the newspapers announced that a great scientist had just died, and they printed a picture of his desk, just his desk, with a book. The book was open and unfinished, and the caption of the picture said, "The world's greatest scientist could not finish this book." Well, I was floored. I was fascinated. Why didn't he ask his mother? I mean, why did he go to the library? What could be so hard that a man could not finish a book? So I went to the library, and I had to know, who was this man? And I found out this man's name was Albert Einstein. And that book was to be the theory of everything.
Yes.
An equation perhaps no more than 1 inch long that would, quote, read the mind of God. Well, I was hooked. I said to myself, this is for me. So when I was in high school, I went to Coverly High School, not too far from Silicon Valley, and I decided to do something. I went to my mom and I said, "Mom, can I have permission to build an atom smasher in the garage?" A 2.3 million electron volt Betatron particle accelerator in the garage. And my mom said, "Sure, why not? And don't forget to take out the garbage." Well, I took out the garbage. I went to Westinghouse. I got 400 pounds of transformer steel. I went to Varian. I got 22 miles of copper wire. And I created a 6 kilowatt, 2.3 million electron volt Betatron in my garage. Every time I plugged it in, I would hear this pop, pop, pop sound as they blew out all the circuit breakers in the house. My poor mom would come home and she would say, "Why couldn't I have a son who plays basketball? Maybe if I give him a baseball. And for God's sake, why can't he find a nice Japanese girlfriend? I mean, why does he have to build these machines in the garage?" Well, that was the beginning. That's how I became a physicist. And now we think we actually have it. It's not accepted by everybody.
The theory of everything, you mean?
The theory of everything. An equation 1 inch long that explains everything. It's called string theory. And I'm the co-founder of one of the main branches of string theory, string field theory. So what is that? We have so many particles, protons, neutrons, electrons. We're just drowning in subatomic particles. They're nothing but musical notes on a tiny, tiny vibrating string. From a distance, a vibrating string looks like a point particle. Close up, you'll see that it's nothing but different modes of vibration. Each vibration corresponds to a different particle. That's why there's so many particles. So what is physics? Physics is the harmonies that you can create on these strings. What is chemistry? Chemistry is the melodies you can play on collections of vibrating strings. What is the universe? The universe is a symphony of strings. And then what is the mind of God? The mind of God is cosmic music resonating through hyperspace. That is the mind of God. That's called string theory.
How metaphorical is that?
It's almost mathematically precise. The equations for vibrating strings are used for violins, guitars, and for the Big Bang and the creation of the universe.
I like that.
It's music. That is the metaphor which drives the entire universe.
Excellent, excellent. So this child, teenager, gets inspired, obsessed, perhaps, and you become a teacher and so on. When and how did you make the move from being, a cloistered academic doing theoretical physics to a popularizer, someone who wants to take it out of the classroom?
Well, I am always a research physicist. That's what I do. I dream about these equations. I go to bed thinking about these equations. But something happened in my life that turned it in a totally different direction. When I was graduating from college, the President of the United States, Lyndon Johnson, said there were no more graduate deferments for college students.
Oh, yeah.
You go to Vietnam. That was my generation. And all of a sudden, there was panic. I was at Harvard at the time. Panic.
So was I.
Yeah,
actually, yes.
Realizing that we're going to go to the hills of Vietnam. And I realized that I could die in some unnamed hill in some swampy area of Vietnam. For what? Why? And I had to ask myself the question, what am I willing to die for? I mean, I could compute, for example, during mortar fire. We would shoot mortars. We would drop them explosive. The thing would shoot into the air. I could calculate in my head how fast it was moving, how far up it went, the distance of impact. I can calculate the entire trajectory of the missile in my head. And then I said to myself, for what? Why? It's all for nothing. What am I going to die for, right? This is an existential shock. Because all my life, I had been preparing for the day when I could work on Einstein's theory, right? And the U.S. government was saying, no.
Maybe not ever.
Maybe not ever, right? And then what happened was, suddenly my doctor, during a routine exam, found out that I had too much sugar in my blood. I didn't know that. So he wrote a letter saying that, no, this person cannot fight in the hills of Vietnam. And all of a sudden, I felt there was a voice up there. A voice up there saying, I'm giving you back your life.
Yeah.
That you were destined to die in some unnamed hill in Vietnam, and therefore, do something about it. Well, I said to myself, oh my God, what can I do? Right?
Yeah, I'm in debt now. What do I, how do I pay this off?
And then a friend of mine at Berkeley, I was getting my PhD at Berkeley at that point, he had a show on KPFA radio. And so he invited me to come on. And I said to myself, I owe a debt. I owe a debt to society. It's payback time, right? Here I am enjoying the luxuries of a nice standard of living. I have a deferment now. I don't have to go to Vietnam. My friends were dying in Vietnam. I had many friends who died in Vietnam.
Oh.
And my life was given back to me. And I had to do something about it. So I decided to start a radio show at KPFA Radio.
a sister station of KPFK where I was for years. That's one thing we have. And you were on KPFK for years as well.
Yeah.
Yeah.
So I said to myself, I got to do something. I just can't work on my equations, which I do anyway. I dream about these equations at night. But I owe society a debt, okay, that I have to do something to make sure that we don't have more children dying in an unnamed hill in some unnamed country.
Let me ask you, we hear a lot about young people, mental illness, loneliness, or just absolute preoccupation with their screens and so on. How are young people relating to science these days? How do you see the people that, young people who listen to you or come to your classes in New York and so on? What's your feeling about that generation?
Well, I think it goes in stages. When we're born as children, we want to know everything. We want to know why the sun shines. We want to know why the stars twinkle. We want to know where we came from, right? So when we're kids, up to the age of about 10, 11, 12, we're born scientists. We are born scientists. And then we hit the biggest killer of scientists in human history. We hit a tremendous roadblock. The greatest killer of young scientists is junior high school. Because when you hit junior high school, 8th grade, 9th grade or so, then science is made boring, memorization useless. Why do I have to learn this? You're never going to use it again in your life, right? The parts of a flower. And then you realize that there's certain principles that allow you to explain all these things, like evolution. So I realized that memorizing things, you got to memorize some things, but for the most part, memorizing science kills the germ of curiosity. Let me tell you a story. Richard Feynman, the Nobel laureate, when he was a child, his father would take him into the forest and point out birds to him, why their beaks are shaped the way they are, why the wings are shaped the way they are, why they eat certain ways, everything about birds. So he was famous among his friends for being the bird expert. Then one day, a bully comes up to the young future Nobel laureate and says, "Hey, Dick, what's the name of that bird over there?" He didn't know. He knew everything about that bird, its eating habits, its coloration, how it flies, its shape of the wings, everything except its name. And so then the bully said, "What's the matter, Dick? You stupid or something?" And in that instant, he suddenly realized a profound truth. Most people think science is giving names to things. Yeah, you got to give some names to things, but no, it's the principle, evolution, that tells you why the beak is this way, why the wings are this way, why the coloration went that way. It's evolution. And if you teach principles, people get it. And then they can make up their own minds whether or not animals obey evolution or not, rather than memorizing the names of all the birds and things like that.
So true, so true.
So I think that in the future, when you get your PhD from Berkeley, where I got my PhD, I would hope that you don't have to memorize the names of all these goddamn subatomic particles, hundreds of these subatomic particles. I would hope that in the future, when you get your PhD, all you have to do is say, string theory. And here's your PhD.
And then go apply what you know about string theory for the rest of your life.
Once you got the concept, once you got the principle. Science is based on principles, concepts, not memorization of names, which is what most people think science is, memorizing names.
And sadly, history, geography, I mean, they kill all of them with memorization.
Yeah, that's right.
What do you teach these days?
I teach quantum mechanics, and lately, we've had a problem with the undergraduates because, of course, we want to, increase the number of undergraduates taking physics courses. So I teach a course called The Physics of Science Fiction.
Excellent.
Because when I was 8 years old, I had two heroes. One was Einstein. I wanted to complete Einstein's dream. The other hero was Flash Gordon.
Yeah.
If you're old enough, you remember Flash Gordon. George Lucas remembered Flash Gordon. Star Wars is a clone of the original Flash Gordon series. I mean, we're talking about ray guns and invisibility shields, rockets to outer space. I mean, what's there not to love in the Flash Gordon series? So that's how I got interested in the science behind science fiction and the future. And then I began to realize the two loves of my life, that is physics and science fiction, were really the same thing. That if you understand physics, you understand science fiction. You can put it into perspective. You know what's possible, you know what's impossible, you know what's plausible. It's no mystery. So when people come up to me and want to talk about wormholes and the fourth dimension and time travel and stuff like that, I say, sit down and let me tell you about time travel and all these things you read about, because there's a kernel of truth to many of these speculative schemes.
It goes right back to those principles, right?
Right. If you know the principles, you're way ahead of everyone else.
Very good. Before we jump into this book, and I know people want to hear, but let me ask you quickly about some other issues that if we get into the book, I'll forget. Where do we stand these days on nuclear fusion?
Well, believe it or not, just a few months ago, we attained break-even in California at the Livermore National Laboratories. We had scores of laser beams concentrate on a pellet the size of a pencil eraser, attain temperatures exceeding the surface of the sun, and created a burst of neutrons, so the energy in equaled the energy out, and that's called break-even.
Yes.
That's a huge step toward fusion power. Because, of course, everyone wants to know, why does the sun shine? Why do the stars twinkle? The universe uses fusion power. They don't believe in uranium, by the way. There are no uranium reactors up there.
Right.
Uranium melts down. Uranium has waste. Uranium creates problems with nuclear proliferation, so on and so forth. No. Mother Nature uses clean energy. Fusion power, which creates almost no nuclear waste, cannot suffer a meltdown, and the basic fuel is seawater, the hydrogen from seawater. What's there not to love? That's what Mother Nature uses to fuel her engines of creation.
And the timeline that you, combining your science fiction and your physics, when might we actually have fusion that lasts for more than a very, very short time?
What happens is the gas that you squeeze has to be shaped like a donut. Now, stars are not shaped like donuts. Stars are spheres. Gravity compresses things evenly. But magnetism is different. Magnetism has a north pole and a south pole. Gravity does not. Therefore, when you create a fusion machine, you have to squeeze fusion in the shape of a donut. That's very hard. Because have you ever tried to squeeze a donut? You squeeze it here, then the other side balloons out. You squeeze it there, and it balloons out over there. It's very difficult. That's why eventually we'll need a quantum computer to calculate all the fluctuations of the plasma so we can squeeze the damn thing evenly and create controlled fusion.
If I hear you right, you're saying we need quantum computing probably to achieve successful fusion.
That's right.
Here's a question that struck me as I was reading was, wouldn't quantum computing be a huge help in mastering quantum computing? You understand where I'm going.
Well, first of all, let me say that if you want to see a quantum computer, just go outside and look at the leaves, the flowers, the trees. Mother Nature is way ahead of us. She doesn't use digital or zeros and ones, zeros and ones. Now, in our galaxy, who uses zeros and ones, zeros and ones? We humans are the only ones who use zeros and ones to compute. That's binary. Mother Nature uses molecules and electron waves, waves of electrons, right? That's what a quantum computer can do. But Mother Nature has a more advanced quantum computer. It's called a flower. Photosynthesis. Mother Nature is always ahead of us in this game.
Oh, absolutely.
But we're using quantum computers that are crude to mimic quantum computers that Mother Nature has already figured out over billions of years, and that is flowers, for example.
Yep. So when did you decide to write this book, and what was the itch that you scratched for this one?
Well, we think we have the theory of everything. We're not positive because we have to prove it, right? People want to have some definite proof, and that means solving these equations. But these equations are so difficult to solve, many people have given up, okay? So my attitude is, put it in a computer. But these equations are so complicated, no digital computer can calculate it. String theory cannot be reduced to zeros and ones, zeros and ones, zeros and ones. You need a quantum computer. A quantum computer to decode a quantum paradox. Only the quantum can conquer the quantum. That is the language of Mother Nature. Mother Nature speaks in the language of waves, waves of probability. That's what makes the world go. And that's why I said to myself, okay, we have to build quantum computers to solve string theory.
Right, I've done all I can do without that tool.
That's right. That's the missing tool, right?
Very good. So, did At this point in your career, does anything surprise you when you're working on a book like this?
Well, what surprised me was how fast things are moving. You realize that, a decade, 2 decades ago, the greatest quantum computer calculation was 3 times 5 equals 15. Now, people laugh. They said, what? You're spending millions of dollars to prove that 3 times 5 is 15? And the answer is, yeah, we were spending millions of dollars proving that because we used atoms to do it. Here's a homework assignment for you people. Go home tonight, bring 5 atoms with you, and multiply 3 times 5 with 5 atoms to get 15. That's real hard. Right? Now we can multiply billions, right? Just in the span of a few years. And quantum supremacy is the point at which a quantum computer beat a super digital computer, hands down, on a certain task. Not a general task, but a certain task. 2 years ago, it was achieved. Shock waves went around the world. The Chinese and IBM and Google were right up there leading the pack, achieving quantum supremacy, which many people thought we wouldn't get in this century. And then we did it 2 years ago. Now we want an all-purpose quantum computer that can compute anything, not just a specific task.
Right.
But quantum supremacy has been attained now.
Okay.
It sends shockwaves throughout the computational community.
As I was reading this and I was thinking about all the problems that might be solved with quantum computing and the clean tech problem that might be solved with fusion, I thought, when we master those 2 things, we'll be in a whole new world, won't we?
That's right. When you watch Star Trek, right, and they land on some primitive planet, and then they analyze the atmosphere, and they found, ooh, hydrocarbons, soot. Yeah, they're going through the Industrial Revolution, right? What happens if aliens land on our planet and they survey our atmosphere and they'll say, oh, this society is pretty primitive. They still use oil and coal, right? So you can dream about an era that you see on Star Trek where there is no oil and coal being burned. It's all fusion. And on Star Trek, guess what? It's all fusion from start to finish.
Great. So let's take on the basics of quantum computing. So what is it? And you've sort of danced a little bit around it, which is fitting since everything is music. But what is the distinction that you say that's quantum computing, this is pre-quantum computing?
Okay, let's take a look at an ordinary computer that computes on transistors, right? And let's get an imaginary transistor consisting of an atom. An atom spins. It can spin up, and it can spin down. That is 1, that is 0. That's how you can compute with an individual atom. This is 1, this is 0. Okay, you got that?
Yep.
Now, quantum computers are such that it go in any direction whatsoever, any direction simultaneously. That is the power of a quantum computer. Now, how many more states are there if you can go like this versus this and this? How many more states are there? Infinitely more states.
Infinite, yes.
And you're doing this simultaneously because you're computing in parallel universes. At this point, it kind of freaks people out. They ask me a question, is Elvis Presley still alive in a parallel universe? That's what we're saying. That the power of a quantum computer is that it computes in parallel universes.
And we're within 10 or 20 years of being able to do that?
We can already do it on specific tasks. We can beat a conventional computer by a factor of 1,000,000, okay?
Right.
But we want an all-purpose thing that can solve any problem, right? So we're not there yet. But we think that, let's say within 10 years, we could have quantum computers commercialized to attack cancer, Parkinson's, Alzheimer's disease, talking about the aging process, whether or not we can extend the human lifespan, create a super battery that'll energize solar power so that we have the solar revolution. All these things are within our grasp once we get a working quantum computer.
When you were describing the parallel universe and so on, it jumped in my head. I hadn't written it in preparation, but everything everywhere all at once.
Yeah, Hollywood has discovered string theory. The multiverse has infected Hollywood, and all the Hollywood blockbuster movies are now based in the multiverse. Because you see, space travel is old hat. We've been there. We've done that. We've been to the moon, right? You can't thrill young audiences by going to the moon again, right? But parallel universes, right? I mean, that kind of like freaks people out. What? You mean another me in another universe? Another counterpart to everything? Yes, that's what we physicists work in. We work in parallel universes, right? And so that's why Marvel Comics and Hollywood have said, yes, that's the new frontier for Hollywood. And guess what? It swept the Oscars this year.
It certainly did. So here's sort of the main course. What are the best case scenarios? What are the worst case scenarios? And worst case could mean either we don't crack the code, we don't ever achieve it, or we do and there's bad consequences. And what are the most likely scenarios?
Well, the best scenario is that we can copy Mother Nature. Artificial synthetic photosynthesis, creation of fertilizers, creating a second green revolution to feed the world. I mean, think about that. Mother Nature creates fertilizers almost for free. We can't do that. We have huge fertilizer plants. 1% of the total energy consumption and production in the world goes to producing fertilizer. In your body, 50% of the atoms of your body come from artificial fertilizers. 50% of every atom in your body. We are so dependent on fertilizer plants. And Mother Nature does it with a leaf. So we have to learn how to copy that to create synthetic photosynthesis and synthetic creation of fertilizers.
So the best case is that we achieve some of what Mother Nature has done within X amount of time and so on.
Right.
What's the worst case? And by that I mean, what would be the obstacle that would stop us from being able to do it? And one thing you haven't talked about is the fragility of atoms that makes the pathway. I think that would be helpful too.
Well, first of all, if somebody sneezes next to your quantum computer, it jiggles the atoms and everything collapses. It becomes decoherent and you got to start all over again. That's why we have to cool it down to near absolute zero.
To cut out the noise.
Right. When you see a picture of a quantum computer, you see the chandelier. That chandelier is not the quantum computer. That chandelier is the cooling system. The quantum computer itself is a little thing the size of a quarter at the bottom of the chandelier, right? So that's how difficult it is to create one of these things. Now, the worst case scenario was investigated by the CIA. We know this because CIA documents have been leaked out saying that yes, they're following it very carefully. If a quantum computer is that powerful, it can break any known digital code.
There's no encryption that quantum computing can't handle.
That's right. So think of the crown jewels of any nation, the most treasured secrets, the nuclear secrets, the wartime secrets, the financial secrets. All of that is coded by these nations, and you can crack the code with a quantum computer in the coming years. And so the U.S. government has issued a directive stating that companies have to prepare for the day. We don't know when. It's not now, the document said, not now, but you have time. Time to prepare for the day when quantum computers can crack any known code, okay? Because when that happens, there are no more secrets.
And what is that preparation? I mean, in other words, you see a way around that. You see a way of defeating that.
Right. The government recommended two possibilities, right? One was to increase the complexity of the code. Codes are done by factorizing numbers. We know that 15 is 3 times 5. But if I give you a number that is 100 digits long, and I ask you to factorize it into the product of two numbers, how long would it take? It would take centuries. Centuries on a conventional digital supercomputer to factorize a number 100 digits long, okay? Quantum computers will do it like that, okay?
So the same tool that will break the existing codes may produce codes that it can't break.
Well, then now the next step is to use laser beams, which have their own polarization, okay, such that anyone who taps into a light beam will see that the polarization vector is altered. You know, when you put on sunglasses, there's striations on the sunglass, vertical lines, you can't see them, but they're vertical lines such that only polarized light can go through. That's how polarized lenses work. They screen out all the frequencies that are not vertical, okay? So if you have a polarized beam of lasers and someone taps into it, the direction of the polarization changes, and immediately, you know, someone's tapping into your system. So you use the quantum to defeat the quantum.
Right.
So that's the fail-safe, to have another laser system that has polarization such that if it's altered, immediately you know by the laws of quantum mechanics that somebody is snooping, trying to steal your secrets.
Okay.
So we use the quantum to defeat the quantum.
Let me just, I know we want to turn to questions in a couple of minutes. Okay. One thing that you get criticized for, I've seen it even in like reviews of this book, is that you're too positive, right? Right? That you're too optimistic, and you don't see how so many things we've done, you know, we've flown too close to the sun, and we've had those unintended consequences. How do you respond?
Well, I like to quote, first of all, from General Dwight D. Eisenhower. He once said, quote, "Pessimists never win wars. Only optimists win wars." So why should I write a book saying it can't be done, it can't be done, it can't be done? End of story.
No, well, no.
There's no more story. It can't be done.
I wasn't meaning it can't be done, but it can't be used for ill, or we don't, you know, we shouldn't, like what's going on right now for the last, 3 or 4 months on AI.
Well, first of all, technology is a sword. It's a double-edged sword. One side can cut against people, the other side can cut against ignorance, poverty, and disease. But when it comes to the internet, I actually differ from most other scientists. Most scientists would say that the internet is also neutral. It could be used for war, it could be used for good. I tend to think differently because the main thrust of the internet is education, knowledge, empowerment. And with empowerment comes democracy, because people who are powerless realize this is my destiny. My destiny is to control the destiny of our nation. That's our destiny. And so that's why I'm saying that the internet has a moral direction. The moral direction is empowerment and democracy as a consequence. Now, some people say, well, can't bad things come in too? Well, let me quote from Deng Xiaoping. He once said that sometimes you have to open the window and sometimes a few flies come in. Yes, a few flies come in, but you open the window. And as a consequence, for example, India and China have created hundreds of middle-class people rising from the ranks of poverty into the middle class for the first time in the history of Homo sapiens. Think about it. For the first time in human history, historians will write in the future that a huge chunk of the human race went into the middle class because of the internet, empowerment, knowledge being dispersed. And that's why I think that the smallest unit of history is the decade. Anything smaller than a decade is random fluctuations.
Just ephemeral, just...
But now, go decade by decade into the past, going back to the 1800s, and then you realize, oh my God, there's enormous progress taking place. I mean, back in the 1800s, we didn't live very long. The average lifespan was about 30 or 40 years of age, for example. As they say, life is a bitch, right? Well, it's true. We didn't live very long in the 1800s. And what do? We had to scrape the soil, which was hard, and eat food that was rotten because there were no refrigerators in those days, no antibiotics, no leisure time. It was rough in those days. And look what happened just several decades later, right?
Yeah.
So that's what I'm saying, that when you look at history, decade by decade, you become an optimist. You see a direction.
So then even the things we're talking about, the breakthroughs are going to be necessary to clean up some of the mess that we've made along the way, are only decades away. So when you take that decades-long perspective, the possibility of new ways of doing things becomes more real.
Yep, that's exactly right. So that's why I'm saying take a look at the big picture, okay? I'm a scientist. We're used to looking at times when it takes time for certain inventions to reach their true fruition. But when they do, they change world history. I mean, when the transistor was invented after World War II, people wondered, what are we going to use it for? Basically, signal ships at sea. We were going to use it for the Navy so we can signal ships at sea, right? I mean, that's the least of our worries now. But that's what people thought because their scope was limited. What I'm saying is when you look at science with a big scope, then you realize enormous power because we're harnessing the laws of nature to change our world. That's the difference. Historians can write about history, but physicists are the ones who make history.
Good last line. Go to questions now.
Thank you. It seemed like in the 40s and 50s there were these titans of physics with Heisenberg and Oppenheimer, Niels Bohr, all at the same time. In addition to yourself, who are the titans today in physics?
Well, you have to realize that there are ebbs and flows, that sometimes a theory takes time to gel and to be tested. We're now in an era of looking at the Big Bang, and it's very difficult to test the Big Bang theory directly. We cannot create universes. Therefore, it's very difficult to make a direct test. But in string theory, for example, Ed Witten at Princeton is, quote, the leader of the pack. He's the one who sets the agenda. He's the one who has opened up so many different avenues for string theory. He's basically number one. But no Nobel Prize yet, because how do you test the theory of reality and creation itself? That's a pretty tall order. The best we can do is to look for dark matter. So I think the next Nobel Prizes will go to people who can nail down what is dark matter. Now, what is dark matter? Dark matter is invisible, but it holds the galaxy together. If I had a piece of dark matter right here, it would go right through my fingers, wouldn't even stop, go right through my fingers, hit the floor. It would go through the floor, go right through the center of the earth, keep on going to China, reverse direction in China, and then come back, and I would catch it right here, and it would start all over again. That's dark matter. We have to figure out what it is, and we think it's nothing but the next octave of the string. We are the lowest octave of music. We are the lowest vibrations. We're stable. We're the lowest vibrations. But the next vibration, the next octave up, is dark matter. And we think that the discovery of dark matter will nail it to the wall. That'll prove that string theory is correct. So there's a Nobel Prize waiting out there for the person who can figure out what is dark matter. So if you ever figure this out, what should you do? Tell me first. We'll split the prize money together, you and me.
Hello, Doctor.
That's what research students are for, isn't it?
Hello, Doctor. Hello, Doctor. So I have a question. Do you think in our lifetime we will see 1 million habitants on Mars?
Well, that's the goal of Elon Musk, that we want to begin the colonization of Mars. Now, first of all, I think we should do it, but I don't think we should rush to do it. What's the rush? Now, the dinosaurs did not have a space program. That's why they're not here today. How come there are no dinosaurs here today, right? Because they had no space program. Now, we do, but we can also look at the trajectory of asteroids, killer asteroids in space. We don't think any killer asteroids are going to hit us for the next 100, 200 years. So we got some time. So the rocket that blew up last month, that was not just a moon rocket. The media got it wrong. That was the moon/Mars rocket that blew up. Elon Musk thinks big. That was the biggest rocket ever built by the human race that blew up last month on national television. What is the name of it? The BFR. B for big, R for rocket. And you can imagine what the F stands for. Now they call it the Starship, but we all know the true name of the rocket. It's the BFR. The point is that the colonization of Mars is inevitable, but what's the rush? Costs keep dropping every year. Why? Rockets are reusable now. Now, when you take a ride in your car, do you junk it after one ride? If you junked your car after one ride, cars would be expensive, enormously expensive, right? That's called the rocket program. Every time we shoot a rocket up, what do we do with it? We throw it away. That's why rocketry is so expensive. And that's why Elon Musk is a billionaire. His rockets are reusable. And that has ushered in a whole new stage of cheap space travel. You know, when we discovered the railroads, we went through 3 stages. One was railroads hauling lumber, troops, ore. That was stage 1. Stage 2 was when rich people said, wow, I can create luxury liners. Stage 3 is mom and dad can now ride on the railroads. That's the history of space travel. Phase 1 of space travel, only the superpowers can go into outer space. Now we're entering stage 2, when billionaires want luxury liners to take them into outer space. That's our era now. And in a few more years, maybe a decade or so, we'll be in stage 3, where you could go into outer space, if you have, of course, some money, you know. Already they're selling tickets. Elon Musk is selling tickets to go to the moon. It is now commercially available to buy tickets. One Japanese billionaire bought out the entire ship. Oh. So the first generation to go to the moon commercially has already been sold, but it's coming. We're hitting stage 2, where rich people can go into outer space.
Really rich people.
Yeah. And then stage 3 is when you and me go into outer space. Or maybe you, not me.
I'd like to know, now that we have quantum computers, begun, and they can process things so fast, you say 10,000 times as fast for some algorithms as a classic computer. Combine that with artificial intelligence, what does this now mean for the future of vaccines and healthcare and genomic editing to improve humanity and prevent disease and cure it and that sort of thing, improve us?
Well, take a look at wonder drugs. How do we make wonder drugs in the laboratory? We get hundreds of petri dishes, put a little bit of a germ in it, and another little bit of a potential cure in it by the thousands. And then we hope and pray, we cross our fingers, and hope that some of the substances we tested kill the germs. That's why wonder drugs cost so much. It's trial and error. In the future, you will push a button, and inside the memory of the quantum computer, it'll test whether or not your wonder drug can kill a bacteria in the memory of a computer. So does this mean that biologists will be put out of a job? Well, biologists who do not use this technique will lose their job, replaced by biologists who do use this technique, because you'll be able to create wonder drugs by just pushing a button. And think about this. Diseases are all at the molecular level, like Alzheimer's disease. Alzheimer's disease is typified by an amyloid gum that gums up the brain. But what autopsy reports, many people die healthy, and their brain is full of of the amyloid proteins, but they're okay, right to the day they died. So does the amyloid protein cause Alzheimer's or not? Sometimes yes, sometimes no. Now they found out that there are at least 2 kinds of Alzheimer's protein. This is new. 2 kinds of Alzheimer's protein, one that curls to the right and one that curls to the left. It's a molecule. The shape of the molecule determines whether you're going to die or not of this chemical. This means that in the future, we'll use quantum computers to separate out the left and the right and perhaps cure the disease of the century. I mean, think about it. When you're in your 80s, about 50% of the people in their 80s have Alzheimer's disease. So this is one of the great killers of society. And quantum computers may give us a cure. And cancer is next on the block. You realize that now with a blood test, a simple blood test, we can detect 50 kinds of cancer in your blood. Now think about it for a moment. Right now, how do we know that you have cancer? Well, you look for a tumor. At that point, it's sometimes too late. You got a few billion cancer cells growing in your body. A tumor is pretty big in terms of cancer cells. Now, for the first time, just a few months ago, the FDA approved a new test for cancer that looks at blood and finds 50 different kinds of cancers. That's today. In the future, a quantum computer will be able to perhaps find thousands of different kinds of cancers, perhaps circulating in your blood. And how will it do it? Maybe in your toilet. Maybe your toilet will be your detection. So 3 times a day, you get tested for cancer. The word tumor could disappear from the English language. We don't say bloodletting anymore. We don't say these horrible words of medicine 2 centuries ago, because we have modern medicine. In the future, we won't say tumor anymore, because it'll be a disease of the past, because a simple blood test connected to your toilet, connected to a quantum computer, will tell you what kind of cancer you have. So cancer will be like the common cold in the future because of quantum computers. In other words, this is big. This is really big. You're talking about Alzheimer's, you're talking about cancer, and the aging process. Why do we have to die? I mean, think about it. It's the second law of thermodynamics. In a closed system, things get old, decay, and die. That's a law of physics. But there's a loophole. A loophole because I said in a closed system, you have to die. In an open system, you can live forever. by adding energy, enzymes, different chemicals from the outside, you can reduce the aging process, because we now know what aging is. Aging is, we didn't know this before, aging is the accumulation of error, mistakes that build up. Mistakes in your proteins, in your DNA, mistakes that build up. That's why we get old. That's why we die. We now can cure many of these diseases at the genetic level. So in other words, aging may be the next target for quantum computers, to be able to stop the buildup of mistakes in our DNA. You see, this is pretty big. We're talking about becoming Mother Nature, rewriting the rules of Mother Nature. That's what we're talking about.
A great deal of it has to do with simulation, doesn't it? That one of the aims is just to simulate what is around us at all times.
That's right. In other words, we want to be like Mother Nature. We want to reproduce Mother Nature at the push of a button so that we can cure the diseases that are caused because of mistakes in the laws of nature. So you see how big this is? We're not talking about, maximizing profit of a Fortune 500 company anymore. That's what digital computers can do. No, we're talking about fixing diseases that have been with us since the dawn of time.
Yeah.
Thank you so much for speaking. This has been wonderful. You spend a lot of your time thinking of really grand universal things like quantum physics, quantum computing. Do you find it tough to, I'll say, think of more mundane things, at least in relation, like human politics?
What's that?
It's an accumulation of errors, just like...
No quantum computer can cure that. Well, let me just say that a lot of politics is a fight over accumulation of wealth, okay? That's what
And
politics boils down to, right? When everything is said and done. But first of all, we have to ask ourselves, where does wealth come from? If you talk to a politician would say wealth comes from taxes. But you see, taxes robs Peter to pay Paul. It's a zero-sum game. So that can't be the source of wealth. If you talk to a lawyer, where does wealth come from? A lawyer would say lawsuits. You sue Peter to pay Paul. But that's a zero-sum game too. Someone wins, someone loses. Now you talk to an economist. An economist would certainly know where wealth comes from. And the economist would say, that's easy, printing money. You just print money. But then that means your children have to pay off your debt. It's still a zero-sum game. I say that true wealth comes from science. Science goes in stages. The first stage of wealth generation was when we physicists worked out thermodynamics, the laws of steam. The steam engine was cooked up by physicists. That gave us the locomotive. That gave us factories. That gave us the Industrial Revolution, the greatest revolution in human history. And then Maxwell and others, physicists, worked out the laws of electricity. And that gave us the electric revolution. Now we have dynamos and motors and generators and light bulbs. That's the second revolution. The third revolution was when we physicists worked out the laws of the quantum, which gave us the transistor. Tremendous wealth coming from the transistor. And now we're into the fourth stage. The fourth stage is physics at the molecular level, meaning genetics, meaning artificial intelligence and nanotechnology. That's the era that we're now entering, wealth generation from that. Then we physicists can work out the fifth wave. Now the fifth wave we're not going to have for several more decades. Probably by mid-century, we'll have the fifth wave of wealth generation. And that is fusion power, okay? That is quantum computers and BrainNet. That is, we're going to connect the brain directly to the internet so that you'll be able to carry out conversations, download movies, communicate with each other mentally. That's the fifth wave. So you see, wealth generation is at the root of politics. Politics is about who's going to get the wealth. What I'm saying is, instead of fighting for the wealth, we should create more wealth by having more scientists, by having more research in science, because that's where wealth comes from.
You know, it looks to me that we have let our technological evolution outpace our moral, ethical, and political
Well,
evolution.
the warfare aspect of our science, right?
Well, our technology. In other words, we have, you name it. Now the current, threat seems to be AI. But even just the fact that democracy has trouble dealing with misinformation algorithms, right? That tap into people's dopamine systems in a way that suddenly that thing that's feeding you is altering, your actions, and democracy has a hard time dealing with that. How do you think we're going to get the moral, ethical evolution that equals our technological prowess?
Well, first of all, I think that the internet has a moral direction. In that sense, I disagree with many people who say that the internet is totally neutral, because knowledge creates empowerment. When people have no knowledge, they are powerless. They don't know which way to go. They don't know who's the source of their problem. They're easily misled. In the old days, kings and queens would just get the crowds all rabbled up by pointing out some fictitious enemy out there, right? People didn't know. They had no way of knowing who the real enemy was, who the real villain of the piece was. They just sacrificed their children to war, right? And so it was the lack of information that helped to fuel kings and queens to grab other people's properties, kill people, grab nations, right? Now we have the internet. Now we have no excuse. It's easy to download information as well as misinformation, but you can download information so you know what's really happening. For example, take a look at Russia today, right? The government has this huge propaganda machine saying that the war in the Ukraine is totally just because they're Nazis. They're Nazis down there. We have to do it for national survival. So what did all the young people of Russia do? They left the country, okay? They're not stupid, okay? So they figured it out. So people have a certain knowledge base that our ancestors did not have. They could be easily misled by kings and queens to die for the glory of the king for some silly reason like that. Now people are wised up. They realize they don't necessarily have to fight these wars. They could leave, or they can get rid of the dictator. And so I think that there's a direction to all of this, that science creates empowerment, education, and education leads to democracy.
Wow. I have to take your decades-long perspective to not look at what's happening with the way that, as I said, misinformation has, sort of tapped into our dopamine system, where people make decisions, get angry, get passionate, hate each other, get tribal over things that aren't even real.
Mm-hmm. And that's how kings and queens used to rule in the
Right.
past. It's much harder for kings and queens to do that anymore.
To God's ears.
Do we live in a holographic universe? And if so, what does that actually mean?
Well, there's two holographic universes. One, the holographic universe of science fiction, where there's a counter world of reality. But there's also the holographic principle in physics. We actually use the holographic principle in string theory, for example, in some of the recent developments. So what is a hologram? A hologram is like a sheet of paper with an image on it, where we reduce one dimension of space-time. So reality is not what you really think it is. If reality is n-dimensional, then there is an n-1 dimensional subset that reflects this. And so what you think of as reality is only a piece of reality. So, so in other words, what you think is real is only a piece of reality, and that's the holographic principle that comes out of string theory. Now, people ask the question, so what? This just means that what you think of as reality is not quite true. Same thing with the quantum principle. When you see something, you think it's real, you think what's happening is real, you know it, right? Well, actually, no, it's not real at all. It's just a fragment of the total reality. Because, for example, your eyes can only see a sliver of the electromagnetic radiation. You cannot see ultraviolet. Bees can see ultraviolet. Bees home in on ultraviolet radiation, but you cannot, right? And some women have not just 3 receptors in their eye, they have 4, okay? And so, not boys, but girls, that a certain fraction of the female population have 4 receptors in their eye rather than 3. Their perception of reality is different from what a boy sees. Wow. Okay? And so what you see is not necessarily what you get.
Yeah, if you think quantum computers can like crack codes and passwords and stuff like this, what are your thoughts on cryptocurrency, digital wallets, NFTs, the metaverse? Does it have staying power?
Cryptocurrencies? Well, first of all, when you look at wealth, wealth really represents something. A dollar is just not a dollar in the abstract. You can buy something with it, something of substance, right? There's something that backs stocks, okay? So when people talk about the stock market, they sometimes call it the slot market. But there's something that you're betting on. With cryptocurrency, you're not betting on anything. You're betting on a fiction, the hope that you'll break the bank and make lots of money on cryptocurrencies. So I tell my friends, yeah, you can invest in cryptocurrencies, okay, just don't expect to win all the time. That sooner or later it's going to crash, and there goes all your savings, because there's nothing backing it. There's nothing backing the cryptocurrency. It's
Except
just air.
the other people playing.
Right. It's musical chairs. When the music stops, okay, there's a mad scramble. Somebody loses. Somebody wins, somebody loses. But mainly people lose. So that was the question you were asking? But also, quantum computers are so powerful, they can also crack the code of cryptocurrencies. So in principle, people who invest in cryptocurrencies can have their wealth dispersed by somebody who cracks the code, because the cryptocurrency codes are also digital. And a quantum computer is beyond digital.
So if crypto lasts that long, it will be hacked by quantum.
Yeah, well, that's why I'm saying that we have to have the quantum fight the quantum, to have optical quantum, optical internet that is proof that it's possible to stop the criminals.
I would like to know a bit about string theory. So there are strings that vibrate to create certain particles, right?
There are strings that what?
That vibrate.
Yeah, all strings vibrate by the quantum principle. You cannot have a motionless string.
So my question is, how does antimatter-matter annihilation work with this?
Well, antimatter is ordinary matter with the charge reversed. I used to play with antimatter when I was in high school. You get sodium-22, which you get from the Atomic Energy Commission. It emits positrons. And I built a cloud chamber, and I photographed it. I photographed antimatter tracks inside a cloud chamber. So antimatter is nothing but one more vibration of the string. In other words, you have anti-strings as well as ordinary strings. Now, negative matter, that is a source of controversy. Antimatter we play with. When you go to the hospital, by the way, and you get a PET scan for your brain, that's antimatter. You have antimatter circulating in your brain that gives you an image of your brain on a PET scan. And that also uses sodium-22. So antimatter is ordinary matter with a reverse charge. Negative matter is something totally different. Negative matter, instead of falling down, falls up. Now, we've never seen that before. We've never seen anything fall up. But at the beginning of the Earth, perhaps there was lots of negative matter, but it simply floated away. What's the purpose of negative matter? Negative matter is the fuel for time travel. If you have enough negative matter, you can go backwards in time. Now, in Star Trek, they call it dilithium crystals or something like that, right? That's a bunch of nonsense. But negative matter stabilizes a wormhole and would allow you to go between universes, okay? Now, of course, we've never seen negative matter in the laboratory. It's hypothetical. But if negative matter did exist, then time travel may be a possibility.
Thank you, Michio. Thank you, Terrence.
Again, the book is Quantum Supremacy, How the Quantum Computer Revolution Will Change Everything. And the website is mkaku.org. That's MKAKU, all one word, .org. This episode was recorded as a Live Talks LA in-person event, May 5th, 2023 in Santa Monica. I've had the pleasure of hosting conversations for them many times over the years, including with Michael Lewis, Yuval Noah Harari, and T-Bone Burnett. You can learn more about their past and future events at Live Talks LA, all one word, livetalksla.org, and link to this conversation by going to youtube.com/livetalksla/videos and scrolling down. To find this conversation and many other interviews and articles, and to join me in pursuit of a world that just might work, go to terrencemcnally.net. Terrence, T-E-R-R-E-N-C-E, McNally, M-C-N-A-L-L-Y, all one word, terrencemcnally.net, or aworldthatjustmightwork.com. Again, all one word, a world that just might work. They're the same website. If you want to receive my weekly email announcement telling you who's going to be on, what we're going to talk about, plus links to 10 or 15 articles I choose each week to flesh out the conversation, sign up at my site or email me at temcnally@mac.com, temcnally@mac.com. You can also subscribe and listen to the Freeform podcast on Apple Podcast and most other podcast sites. You'll find years of podcasts at my site or those sites and listen anytime, anywhere. Archives include Naomi Klein, Bill McKibben, Van Jones, Connie Rice, Greg Boyle, George Packer, on and on. You can also follow me on Twitter at McNally Terrence. Thanks to Kiana Williams in production and George Vasilopoulos at Progressive Voices, and most of all to you, my listeners. Please share this podcast widely.